Okay, so in this short supplementary video, I would like to explain how to invert small matrices by hand. In the main course, we talked about the concept of a matrix inversion. So we basically discussed the fact that if we have a matrix A, which is square, so we have something like this, n times n, then under certain conditions, which we actually don't discuss and which are the realm of real mathematics, we can invert this matrix, so we can compute another matrix, A to the power of -1, that if we multiply A by, we get the identity matrix in n times n. So if we basically do this, we get the identity matrix. And we also discussed that also the reverse yields the identity. Okay, so we discussed the idea of this inverse of a matrix, basically something like division, but extended to matrices. And we also discussed how we can compute the inverse of a matrix if the matrix R that we want to invert is actually diagonal. But we have not discussed how to compute the inverse of a matrix in a general setting. And actually in a full general setting, this is also far beyond the contents of the course. There are many algorithms developed in numerical mathematics that efficiently and numerically stable compute matrix inverses. Usually, if you are doing some model-based data analysis, you will use some software, some scientific computing software, such as MATLAB or NumPy in Python, which has routines that compute inverses of matrices. Nevertheless, it's nice to have seen how to compute the inverse of a matrix directly by hand, and this is actually what we want to at least demo in this short video. So let me get rid of this. Actually, we can just scroll up and give it a title. So why small matrices only? Well, because it's tedious and we want to finish at one point. So there are different ways to compute matrix inverses, and here I will discuss one practical approach, which is kind of general purpose as long as the matrix is relatively small. So we assume in this case our matrix that we want to invert is a 3 by 3 matrix. So 3 by 3. And of course that's, I mean, we could extend it to 4 by 4. It gets more work, 5 by 5 gets more work, and so on. So 3 by 3 is something that is kind of feasible. And we assume that also A is in fact invertible. So studying whether A is invertible or not, that's again something that we leave for mathematics. It's interesting and there are many ways to determine that. But here we assume that it's just the case, so that we can actually, that there is an inverse to the matrix R. And to make this very concrete, we use an example, and we use the following. So our matrix R that we want to invert is this matrix. So in the first row we have 1, 0, 2, 2, -1, 3, and 4, 1, 8. Yeah. And now we want to compute a matrix so that if we multiply the matrix that we compute with A, we get the identity matrix. So we get I3. A 3 by 3 matrix was just once on the diagonal. It's kind of a little game, and we don't discuss here why this game works, but we at least define the rules of the game. So what we are allowed to do in this game is to use 3 kinds of operations on A, and at the same time on a matrix that we write next to it. And if we then manage to get with these operations the matrix A into a specific form, then on the right, and we apply the same rules there, we have the inverse. It's magic because we don't discuss why it works, but still it works, and we will see that it works. Okay, so the first thing is that we write the identity matrix next to our matrix that we want to invert. So this is the matrix we want to invert. This is the identity matrix. And now we are allowed to do 3 things. 3 operations are allowed. First operation allowed is exchange rows. Second operation that is allowed, multiply a row of A by a scalar number. And the third operation that is allowed is adding or subtracting a multiple of another row of A from any row of A. Okay, so these are the rules of the game. As I said, we have to apply these, or we can apply these different rules to the matrix that we want to invert, this one. We have to at the same time apply them to this. And our aim is to convert, using these rules, convert the matrix that we want to invert into the identity matrix. Yeah? So we have to somehow by intuition come up with a sequence of operations from the set of 1, 2, 3 that turns the left that we see here into the identity matrix. And this is something that one can practice, and then one gets very efficient in that, and that's what I think students in linear algebra and mathematics do in early on in their courses. And then, yeah, they seem to be very clever because they can do that, but really it's just a small game. So let's do this game. Actually what's helpful is to kind of guide this process of applying these operations to the matrix of interest is that we first try to get this column into this form so that it's the first column of an identity matrix, and once we manage to do that, we try to achieve the same thing here, so to get this into this form, and finally we try to get this into this form. Yeah, good. So that's the plan. Then let's go. So we see that definitely in the current form there are things that are not quite working. So there's actually a 2 in the second row of the first column. So what can we do against that? So how can we get that away? Well, what we can do is multiply the first row by 2 and subtract the result from the second row. Yeah. So basically we add -2 the first row to the second row. Yeah. We can write it maybe like this. So -2 times first row. So this is really, so this is a Roman 1, so this is really not mathematics, this is kind of a game, and this is the notation we use. But what do we get when we do that? So we get to our next step. So the first row stays the same because we're not doing anything to it. And now we need to subtract -2 times 1 from 2, so we get 0. We have to subtract -2 times 0 from -1, so we stay at -1. We have to subtract -2 times 2, so -4 from 3, so we get -1. And like I said, the trick is to apply the same operation to this identity that we just wrote next to our matrix of interest. So we have to now subtract -2 times 1 from 0, so we get -2. And then we need to subtract -2 times 0 from 1 and -2 times 0 from 0, so this remains the same. Yeah, that would be our first thing to do. Now we see that also in the third row of the first column we have a number that is not 0, so we can also get rid of that if we subtract -4 times the first row from this. So then we get 0 here, and we have already our first column in the form of the identity matrix, but we have to compute the rest. So 0, so -4 times 0 plus 1 is 1, and -4 times 2 plus 8 is 0. And again, we have to apply to the this supplementary matrix. So we have -4 times 1 plus 0 is -4. -4 times 0 is 0, and -4 times 0 plus 1 is 1. Yeah. So now we have used adding and subtracting row multiple from any row of A twice, and we actually have the first column in the form of the identity matrix. Now actually we see that in the third row of our new thing we have something that looks like the middle row of a 3x3 identity matrix. So what we can do now is exchange, because we are allowed to do that, so we're allowed to exchange rows. So we exchange these two rows. So what we then get is the following. Of course, we also have to exchange the supplementary matrix. So we get here. So I'm checking whether I'm still on track. Yeah, that looks good. Okay, and now we see that we still have a non-zero here. So we are now basically concerned with getting our second column into identity matrix form. So what helps here is if we add the second row to this. So we add the second row to the third row, and from this we get again our 1, 0, 2, 1, 0, 0, 0, 1, 0, minus 4, 0, 1, and now we add this, so we get 0 plus 0, we get minus 1 plus 1 is 0, we get minus 1 plus 0 is minus 1, and we have to do the same thing here. So we get minus 2 plus minus 4 is minus 6, we get 0 plus, or 1 plus 0 is 1, and we get 0 plus 1 is also 1. To work on my brackets, they look horrible. Good, so now we are almost there, but there are still two problems. So we have a 2 here that needs to be a 0, and we have a minus 1 here that needs to be a 1. So what we can do is, of course, add twice the third row to the first row, which then gets the 2 out of the way. So we get 1, 0, so these 2 zeros in the beginning of the third row now help us because they don't do anything anymore, and we get a 0 here. And then we have to do 2 times minus 6 is minus 12, plus 1, that's minus 11. And then we have 2 times 1 plus 0, that's 2, and we have the same thing here. Sorry, we didn't do anything with the second row. We can actually in the same step now get away with this minus 1 by just multiplying this row with minus 1. So recall that this was one of the allowed operations, so multiplying row of A was allowed. So we do that here. So we get 0, 0, 1, 6, minus 1, minus 1. Good, and so now we actually achieved, oops, there's something wrong. No, there's something wrong in my script, I think. Wait a second, what's happening here? No, everything's fine. There's a little typo in my script. So now we achieved the aim of our game. So we now have the left turned into the identity matrix, and we have found a matrix here that we postulated would be the inverse of A. Now it's actually good to test whether this is actually the inverse of A. So let's test that. So let's first write down our matrix A again. So this is where we started from. So it's 1, 0, 2, 2 minus 1, 3, 4, 1, 8. So let's write that up again. So what we now want to do is call this, maybe call it B for the moment, because we are not quite sure whether it's actually the inverse, and we only want to see whether it's the inverse. So this was our matrix. No, that was not our matrix A. Our matrix A was this. So that was our matrix A. And now let's see what happens if we actually do the matrix product A times B. So that would be 1, 0, 2, 2, minus 1, 3, 4, 1, 8 times minus 11, 2, 2, minus 4, 0, 1, 6, minus 1, minus 1. Oh, Jesus, these brackets kill me. How can I... So then let's compute that. So we have 1 times minus 11, that's minus 11, plus 0 times minus 4, that's 0, plus 12, so minus 11 plus 12, that's 1. Then we have 1 times 2, that's 2, 0 times 0, that's 0, 2 times minus 1, that's minus 2, so we have 2 minus 2, that's 0. And here we have 1 times 2 plus 0 times 1 plus 2 times minus 1. So that's again 0. 1, 0. Yeah. Then in the second row we have 2 times minus 11. 2 times minus 11, that's minus 22, plus 4 plus, what's going on? I'm confused, sorry. So 2 minus 3, what am I doing? So 2 minus, sorry, again. So we're now doing the second row. So 2 times minus 11 plus minus 1 times 4. So that's plus 4, and 3 times 6. So that's 18. Yeah, and that's then going to see that this is 18 plus 4 is 22, minus 22 is 0. Then we have rid of that. Then we have 2 times 2 is 4, plus minus 1, 0, that's 0, plus minus 3, so that's 1. And then we have 2 times 2 minus 1, that's 3, minus 3, that's 0. Okay, so we have the second row also fine. Now in the last row, Jesus, these numbers get a little bit too large for my brain, so I have to write them down. So 4 times minus 11, that's minus 44. Plus 1 minus 4, so that's minus 40. No, that's minus 48, sorry. So that's minus 44, minus 4, that's minus 48. Plus 8 times 6. So 6 times 6, that's 36, plus 12, that's 48. So again, we get a 0 here. Then we have 4 times 2, that's 8, plus 0, minus 8, that's 0. And then we have 8 plus 1, that's 9, minus 8, that's 1. Jesus, that was hard work. So, but the important thing is what we see is that actually our matrix B that we computed here, so this thing here, if we now multiply this with our matrix A, we actually get the identity matrix. Yeah, as a little exercise, I would recommend that you compute B times A and convince yourself that this is actually also yielding the identity matrix 3. That's a little exercise in matrix multiplication. Yeah, but then we can, once you tested that, you can be quite confident that this on the right hand, what we computed here, so this B is actually the inverse of A. Yeah, so that was now a little tutorial on on how to compute the inverse of a matrix by hand. But as you saw, I mean, there is some work involved. But yeah, if you want to train yourself, you can do that. So again, to recapitulate how that works. So you first start with an invertible matrix. So let's maybe use this here. So you start with an invertible matrix here. You write it down. And next to it, you write the corresponding identity matrix. Then you use these rules and apply them both to the matrix that you want to invert and this initial identity matrix. And you set yourself the aim of converting the left thing here into the identity. And to guide this and not just start fiddling around, you start first to get this into, so get the first column into the form of the identity matrix. Once you achieve that, you do that for the second column. And once you achieve that, you do that for the third column in this case. Or if you dare to go to higher or larger matrix sizes, then of course you have to go on until you have done all columns. And then the right thing here is actually the inverse. And you can then check that by computing the matrix product A times this and this inverted matrix, presumably times A. Yeah. Okay, it's tedious, and like I said, in general, probabilistic modeling, you will use a computer to do this work. But yeah, sometimes, and also sometimes to impress people, you can do it by hand. Okay, good. That was all I wanted to say.